MAVEN is a Mars orbiter, not designed to take pictures of Mars, but really with chemical sensors to understand how the present atmosphere is escaping from Mars, and then through modeling try and extrapolate that back in time and try and understand whether the ancient atmosphere of Mars was similar or different than it was today. MAVEN stands for Mars Atmosphere and Volatile Evolution Mission. The NGIMS experiment on MAVEN is the neutral gas and ion mass spectrometer. And this experiment is a quadrupole mass spectrometer with 2 ion sources designed to look at both neutral gases and ions in the upper atmosphere of Mars. In fact, as we dip down into the atmosphere, we will measure the altitude variation of those chemical constituents. We'll look for the composition. We'll look for how that composition changes with solar events like big solar flares and solar activity. And we'll do that for a whole Earth year on many, many orbits around Mars.
So the philosophy of NASA's Mars program has been follow the water. But where did the atmosphere go is still a lingering question. And so MAVEN is designed to figure out whether or not that atmosphere could have escaped away to space.
The MAVEN payload, all of the instruments on it are designed to examine the processes by which gases escape from Mars. When we look at the ultraviolet light, we can tell what the atmosphere is composed of. We can also tell its temperature. Measure variations in the composition and temperature as we look at different parts of the atmosphere at different seasons on Mars, different times of day.
The imaging ultraviolet spectrograph is the most powerful ultraviolet spectrograph to be sent to another planet. It's got a very high spectral resolution that allows us to look very closely at an emission from hydrogen. And we look so closely that we can tell the difference between hydrogen and heavy hydrogen called deuterium. And by measuring the ratio of heavy hydrogen to light hydrogen, we can get a good guess of just how much water has escaped from the planet. Now this has been done before in the lower atmosphere, but it's never been done in the upper atmosphere where the escape is actually occurring. So that's going to be a first for MAVEN.
We're looking at Mars today, and we're looking at how the solar wind strips away what little atmosphere there is today, and we'll try to roll that back in time and understand what an early Mars might have looked like, and whether a magnetic field like the Earth has could have protected that atmosphere from the solar wind.
Magnetic fields can be measured in a variety of ways, and the most simple way is with a compass.
The Earth's field is global in nature, so it has a North Pole and a South Pole, and wherever you go on the surface of the Earth with a compass, it'll point to the North Pole. But on Mars, if you were to walk around with a compass, it would haphazardly point from one anomaly to the other as you walked across the surface. So it's not quite as useful as a compass on Earth. MAVEN is carrying a pair of magnetometers. Now the spacecraft itself generates a magnetic field, so we have to put those magnetometers as far from the spacecraft as we can. And we've done that by putting the sensors at the very outer end of the solar arrays.
The magnetometers, even though they're small, simple-looking instruments, there's actually a great deal of sophisticated electronics and testing and calibration that goes into building them. They're so sensitive that we ask everyone to use non-magnetic tools when they're working on them. Even if you had a tiny little fleck of metal that came off of your screwdriver, that would be enough to be noticeable and detected by the magnetometer.
There's no Maytag repairman in space. So we punish these instruments before we pack them up and launch them, because we're not going to see them again, and we have to make darn sure that they're going to work.
As a scientist, as the person who will eventually be receiving this data and using it, it's very humbling and gratifying to see all these other people working very hard to try and make sure that we get the data that we would like to get here at Earth.
Even though it's not obvious just by looking at it, scientists think that Mars, a dry, dusty planet, may have once looked a lot more like Earth, with a blue atmosphere, thick clouds, and possibly even water. Scientists also think that Mars lost its atmosphere over the course of billions of years, gradually transforming into the red planet we know today. NASA's MAVEN spacecraft will help provide clearer answers regarding Mars's climate history, and scientists think several processes have had an effect. For example, there are a series of what are known as plasma processes that can slowly strip away a planet's atmosphere. These processes are started by the sun, which emits light in the form of high-energy photons. When a photon at an extreme ultraviolet wavelength enters a planet's atmosphere, it can run into a molecule that makes up the atmosphere's gases. The molecule absorbs the photon, and the energy from this impact can kick off an electron, leaving behind an ion. This stray electron will eventually recombine with another ion, and the energy the electron gives to this reaction is sometimes enough to split the molecule into its component parts, give those parts a lot of speed, and launch them out into space. And although this process occurs continuously in most atmospheres, with the self-maintaining cloud of ions and electrons forming a planetary ionosphere, the escape of atoms over billions of years can contribute to the overall loss of a planet's atmosphere. This could even turn a blue, water-covered planet into a planet just like Mars, and MAVEN will help us figure out exactly what happened. One way that an atmosphere can be lost to space is through a series of what are called neutral processes, which are processes that involve neutral particles rather than charged particles. On Mars, for example, atoms and molecules of hydrogen gas can be found in the upper atmosphere, and they often collide with each other as they make their way around. For the most part, the molecules are still bound to the planet by gravity. However, if a fast-moving molecule collides with another molecule at the right angle, the molecule may have just enough speed to leave the atmosphere and be lost to space. As this process continues over billions of years, it, along with many other processes, can contribute to the disappearance of a planet's atmosphere. And since the hydrogen in the atmosphere ultimately comes from water in the lower atmosphere, it may also contribute to the loss of water over time.
One of these processes is called sputtering, where atoms are knocked away from the atmosphere due to impacts from energetic particles. In our solar system, the sun constantly emits high-energy photons. When one of these photons enters the atmosphere of a planet, it can crash into a molecule, knocking loose an electron and turning it into an ion. Ions by themselves don't do much, but when a magnetic field is nearby, they'll spin around the field. Conveniently, the sun generates a giant magnetic field that is carried by the solar wind. As the magnetic field sweeps past the planet, some ions will get carried away. Other ions, depending on where they form, won't get carried away, but will hit the top of the atmosphere. These ions can then crash into other molecules and fling atoms everywhere like a cue ball in a game of pool. Some of these atoms can be knocked, or sputtered, into space, causing atmospheric loss. And over billions of years, this could have caused quite a bit of change, especially since the solar wind may have been more intense early in our solar system's history. Scientists think that all of this may have caused Mars to gradually transform from what may have been a very nice place to live into the dry, dusty world we know today. And MAVEN will study this process and tell us how it really works.
The closest place we can look in our solar system, the place that we can get to easiest, that has an atmosphere that has evidence for past water on the surface, is Mars. If the ancient atmosphere of Mars was much heavier, the potential of Mars to support life might have been much more favorable. And so the MAVEN mission is designed to really let us understand current escape processes on Mars and then extrapolate back to very ancient Mars to try and understand the conditions that were present back then.
We've never sent a spacecraft to Mars just to explore its upper atmosphere. If you imagine Mars as having had a thicker, warmer atmosphere early in its history, where did the atmosphere go? Where did the water go? And there are only two places it can go. The atmosphere can go down, or it can go up and be lost to space. MAVEN is the Mars Atmosphere and Volatile Evolution mission. We're trying to understand basically why the climate changed on Mars, why Mars appears to have gone from an environment that was habitable to microorganisms at least, to one that is the cold, dry, uninhabitable environment we see today. By looking at the nature of the upper atmosphere today and how gases can be lost out of the atmosphere to space today, we learn about the processes that control the atmosphere, and we're going to have a good understanding of what the history of the atmosphere has been.